Hello, fifth graders. It's Cabbage Chemistry Lab number 5 today. I kind of cheated and sent you a pre-made video about acids and bases for lab number 4. They did a really good job of explaining acids and bases in ways that would just take me a really long time. So I just thought I'd poach something from the internet and pass it on to you guys. So I hope that was kind of clarifies the chemistry behind acids and bases. Remember, pH is percentage of hydrogen, and acids tend to have more hydrogen in the water solution, and bases have less hydrogen in the water solution. So that's kind of the basics of that. This next lesson is the finale. It's really fun. It's really exciting. The first part of this lesson, I am going to show you a little video that I did last night of me making cabbage juice. It's not the best video in the world, but I made this beautiful purple cabbage juice, and I just want to show you how I did it. I was going to show you how I strained it, but I had technical difficulties. So when you are done blending your cabbage, all you're gonna do, and I'm just gonna show you this now, all you're gonna do is you're gonna take your cabbage juice that I had it in this blender, and then you're gonna pour it into a bowl through a strainer. So you just wanna get all of the pulp of the cabbage out and just get that beautiful purple juice. And that's really all you do. If you don't have a nice strainer like this, you can use a colander, and you could put a coffee filter in the colander. I don't drink coffee, so I don't have any coffee filters around. And then you could strain all the big pieces out. You could also use a paper towel. So you could use a colander, put a paper towel in the colander, and then pour the cabbage juice and just let all the liquid drip through, and then you just have this beautiful purple cabbage juice. All right, so I'm going to just show that to you again. I don't know if you can see the beautiful purple color of this stuff. This cabbage juice is a pH indicator, and the scale is a little different than the scale that you're used to seeing with regular pH scales. The colors are a little bit different, and we're gonna see these come to life with this next lesson. I'm doing all of this by myself. I don't have any film crew videoing me, so I'm gonna have to set my camera up in a way where you're not gonna be able to see me, but you're gonna be able to see all of the stuff that we're gonna experiment with. So I'm hoping that you will just follow along as we go. This is a lot of fun. All right. Hi, fifth graders. Right now we are going to make our cabbage juice. Cabbage is a magical vegetable that has a very special scientific property. It can be a pH indicator. You know the pH scale that you played with the pH strips in lesson 3, I think, lab 3. Cabbage has its own color scale. It has a chemical in it called anthocyanin that has the ability to detect acids or bases in a whole bunch of different substances. So we like to make cabbage juice around here. It's a beautiful purple color, and all I do is I take some leaves off this cabbage. This cabbage has been in my fridge for a very long time. It's not a very crisp cabbage, but I'm just kind of putting, I would just put 3 leaves because you're probably going to want to play a lot. I'm making kind of a hearty juice, so I can play a lot and use it in a lot of different substances. So I take about 3 big leaves like that, and then I pour, this is hot water from my hot water kettle. You can boil water on a stove. I like to use hot water because it extracts the color more. I put it into a blender. It can be any kind of blender. It's probably not enough water. That's probably good. And I'm going to blend it. You can see that beautiful color that it turns. It doesn't have to be blended for very long. I just try to make it a nice purple color, and then I kind of let it sit and steep, so it's really extracting that purple color out of the leaves. And then we're gonna strain it, and that's pretty much all you do. All right, I got set up in such a way that you can see me. You can see all of the things that we are going to do today. I'm going to show you what you need right now, and I'm hoping that you'll be able to set this up in your own kitchen. It's not very hard. I don't think it'll make your parents crazy, as long as you clean up your mess when you're done. So the first thing I want you to have is your data collection chart that you made with the other labs. Here's that first section that we filled out. And then today we are going to fill out these 2 columns right here. So have these ready to go, okay? I have this for you, and I'm gonna kind of show it to you as close as I can. This is our acid or red cabbage color pH indicator chart. You can see that the orangey colors over there near 0 are acids, and that yellow color over there is a strong base, and everything in between. So I'll try to show that to you throughout the day. You're gonna need baking soda, okay? And this isn't very scientific, I forgot my spoon, but you're gonna wanna stir your baking soda up, because remember, it's a mixture, it does not dissolve in water. So you're gonna wanna stir that up, okay? I'll use that as my stir stick. I have milk of magnesia, which is that medicine that is good for acidy bellies. I also have Dawn dish soap. You could also use hand sanitizer if you have a lot of it. I can't find very much of it, so you can pick whichever you want. Water, which we have to have because this is kind of our control. This is our neutral substance. Apple juice. You can use any kind of juice. Apple juice, you could even use soda here. You could use 7-Up or Sprite or Coke or whatever. I happen to have apple juice, so I just want to see what it's gonna do, but soda is an interesting thing to test. Vinegar, and I have lemon juice right here. Okay, so this is my lemon juice, and this is the cabbage juice that we made, and you're gonna want a measuring cup. It doesn't really matter what size it is. I picked a 1/3 cup. You could use less or more. I just want to stay consistent across the board, just because that's what we do in science. We try to stay really consistent and have these controls that make it consistent. All right, you're also going to need a pencil. Okay, shall we get started? The very first one I'm going to do is water. I'm going to just show you how clear that water is. Okay. I'm going to pour a 1/3 cup into my cup, and then I'm going to pour this in, and we're going to see what happens to the water. All right, I don't know if you can see the color through the window. I should have a little flashlight so you can see the color. It's really just stayed the same color as the cabbage juice. So there was no real change. So what I'm gonna do here in my chart is under water, which is the first one, I'm gonna say the color is purple. And the pH I'm gonna go here is, I'm gonna go right in between that 6 and 8, and I'm gonna write a 7. And I'm gonna write that it's neutral, okay? So do you see how I did purple, and then I wrote 7, and I wrote an N for the fact that it's neutral. All right, the next one, should we test this Dawn dish soap? I did mix a little bit of water in the Dawn dish soap. I'm curious to see, I don't think I've ever done it with this blue soap, so I'm very curious to see what's gonna happen. All right, are we ready? You see any color changing? It's turning kind of turquoisey. My very official stir stick. This kind of just mixed it. Dawn dish soaps tend to be close to basic, kind of a little bit more neutral. So there is kind of a basic neutral look to that. It's kind of a turquoise color. I'm gonna put a little drop of it on this paper so you can see that it's kind of like a turquoise color. Okay, so I'm gonna put, and we might test some other dish soap just to see what happens with that. Okay. Dish soap is kind of blue. I'm going to just say blue. And I'm going to say that it's a number 10 and it's a base. So you can see that I put blue 10 base. Okay. Now let's try apple juice. Let's just see what happens with apple juice. Are you ready? Oh my gosh. Did you see it change color instantly? Look at that beautiful pink color. I'm gonna kind of assess it with this chart, and it looks like it's kind of identical to that number 4. Okay, so we have an acid. When you're drinking apple juice, you're drinking a weak acid. So here I'm gonna look, this is at my apple juice one right here, and I'm gonna write pink. I'm gonna do a number 4. I'm gonna write acid. Okay. You see that? Okay. Well, this is very exciting. All right, milk of magnesia. Are you ready for some really cool, mind-blowing stuff here? I'm gonna pour this right here, and I'm gonna pour it in. Are you guys ready to watch? Oh my gosh, it is turquoise. I'm gonna stir it. Oh my gosh, look at that beautiful green color. Does that make you want to drink that? See, I wonder what it does, what milk of magnesia does when it hits your stomach. Look at that color. What do you think you would rate that as? It matches that number 12 pretty darn well, doesn't it? Awesome. Milk of magnesia. It's a base, so it's a neutralizer when you have it with your, if you have acid belly from the movie theater. Okay, so where's my milk of magnesia? It's right here. It's this one right here. So I'm going to write green, and I'm going to write number 12, and I'm going to write base. All right. Should we try vinegar now? Let's look at this. Okay. Here we go. You ready to watch? Oh, beautiful. You know, this is a very similar color to the apple juice. It's hard to tell which one's different, and they can change over time. They're very similar. Let me just smell. That's definitely vinegar. I'm looking at them in the light, and this almost looks like a lighter pink. So I'm going to say that it's a little bit more acidic than the apple juice. It's just a touch lighter. Okay, so I'm going to look for my vinegar one. I'm going to go across here. Pink. I'm going to do dark pink for apple juice, and I said that apple juice is number 4, and it's an acid. And I'm going to do light pink for vinegar, and it's actually getting lighter as I look at it. So I might give this one a number 3 and say that it's an acid. Okay, I'm taking my notes. All right. Okay, which one do you want to do now? Do you want to do baking soda? I'm stirring my baking soda. And I'm going to pour this in here. Are you ready for this? Oh my gosh, look at that beautiful turquoise color. Isn't that beautiful? It's kind of a beautiful turquoise. I'm gonna kind of match that. It almost looks like the dish soap. It looks very similar. I think I'm gonna stir it up again, see what happens. It's just a really nice turquoise color. I think I'm gonna call that kind of a number 10, maybe an 11 in between those two colors right there. So baking soda is right here, and I'm gonna write green blue. I'm gonna do like a number 11, and I'm gonna say that it's a base. All right, awesome. And finally, we're gonna do lemon juice, and we're gonna see what happens with lemon juice. Did you predict that lemon juice was pretty acidic? I would hope so, because that's what, to me, acid tastes like lemons. All right, here we go. Oh, look at that beautiful pink color. Nice. Sometimes it's hard to tell the difference between all of these, but in my sunshiny window, it's the lemon juice is the lightest pink of all. So it goes apple juice, then vinegar, then lemon juice. So I'm gonna say right here, lemon juice is light pink. And I'm gonna call it number 3, and I'm gonna call it an acid. All right, there you have it. We're gonna do some special experiments when we're done with this. But right now, what I want you to do is I want you to compare your hypotheses to what actually happened. And right here, I wanna see if you guessed correctly or not. Do any of these surprise you? Did you maybe think that baking soda was an acid? Or did you think that vinegar was a base? Or did you think that dish soap was an acid? There's sometimes some big surprises, but I want you to kind of look at this and write down all of your conclusions right here. So I want you to say, was your hypothesis correct, and write yes or no. And I just want you to know that if your hypothesis was incorrect, that's not an incorrect answer. That was just your guess, and the experiment changed your guess, and there's nothing wrong with that. That's what science is all about. So I'm gonna let you work on that, and I'm gonna get set up for the next little experiment. All right, what do you notice that's different right here? Yep, I have safety glasses on. So I wanted to show you a much stronger substance. This is bleach. This is a lot of bleach. When you clean with bleach, you usually only clean with just a little tiny bit per a lot of water. So this is a very toxic amount of bleach. Even breathing it in is not that healthy. So if you're gonna use bleach, make sure your parents are around, or maybe you don't even have to use it. You can just watch what I'm gonna do. But I just let's take a hypothesis. Do you think that bleach is a strong acid or a strong base? So I'm gonna take what color do you predict that this will become? I want you to make your prediction. Maybe you learned in that acid-base video what it is already, and you're surprised by it. But I'm gonna take this. I'm wearing my safety glasses in case it splashes. And I'm gonna pour this in. We'll pour it this way so you can see. Oh my goodness. It turned a golden, and it's still changing color. Now it sort of looks like apple juice, and it's gonna constantly change. So what is it closest to? You're probably thinking that it's that orange color, but we're gonna watch it change. Oh, look, you can see that it's slowly going from orange to this yellow color, okay? So bleach is actually a very strong base, okay? So there is your bleach, and it's turning more and more and more yellow. So I'm gonna put that down here in my column. I have yellow, and I'm gonna say that it's a number 14 of a base, okay? So when you have a very strong base and you have very strong acids, we don't have the strongest acids around. One of the most famous strong acids is called hydrochloric acid. Maybe you've heard of it. I encourage you to look at YouTube videos of hydrochloric acid melting tables. I mean, it's nasty, corrosive stuff. It will totally dissolve. If you put hydrochloric acid, I think, in a glass bottle, the glass bottle will disintegrate. I don't know that for sure, but it is a very corrosive material. Bleach is a very strong base, but it's not the strongest base around. But when you have it on the strong ends, they're very dangerous, toxic substances. When they come closer to the neutral, that's when you and I can consume a lot of these bases and acids. All right, so now we have a full spectrum. You have this rainbow spectrum of acids and bases. And now what I'm gonna do is set up for a really cool experiment. So before you do any crazy mixing, because I know you're gonna be tempted, you're gonna wanna pour these into each other. There's some specific ones that you don't want to miss. So hold tight, and I'm gonna get set up for a very specific reaction that's super duper fun. So don't mix any of these up right now, okay? All right, I took the bleach away, and for this next experiment, you're gonna want a bowl because there's gonna be a little bit of a chemical reaction that happens. So what I'm gonna have, the baking soda in the bowl, put the baking soda in the bowl, and I want you to pour the lemon juice into the baking soda. Remember, you need a bowl or a tray because something fun is going to happen. What do you predict is going to happen when I pour this lemon juice into this baking soda? All right, should we do it? Are you ready to watch? I'm going to put this up here so you can watch really close. Oh my goodness. Did it change colors? Turned kind of a cool purpley color. And do you see how it neutralized? Do you see how we had that beautiful turquoise, and then we had that pink, and now we have a purple that's a lot like this cabbage juice. So that was a neutralization reaction between an acid and a base. All right, that smells lemony right there. Okay, now this is one that you are not gonna want to miss at all. All right, so what I did here is I split my milk of magnesia into 2 cups because my cups were too full. So I just wanted to do that, and that also gives me the chance to do this twice because it's so cool. So if you have a lot of milk of magnesia and you want to see this experiment twice, it's really fun. So I'm going to put my milk of magnesia in my tray. I only have this white thing so you can see the color more, okay? And then I'm going to take my vinegar solution and my unofficial stir stick, which I have right here. Very scientific. Okay, and what I'm going to do is I'm going to pour half of this vinegar into this, and you have to just keep watching. I'm gonna pour and then I'm gonna bring it up so you can watch what happens. So, are you ready to watch? Keep watching, don't lift your eyes. Stirring, 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 stirring. Watch what happens right in front of your eyes. No, you didn't go crazy. It just went from a beautiful pink to this turquoise and then went back to blue. All right. I want to do that again, but I want to put more vinegar in this time. So I'm glad I have another option. I'm going to put a lot more vinegar in. Let's do this one more time. And maybe I'll stay a little bit down right here. Okay, are you guys ready? Look at how purpley pink it is. I'm stirring, 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 stirring. And now look at that color change. It went from purple to turquoise instantly. So it neutralized and then it went back to the base. So it's saying that that base is a little bit stronger than the vinegar was. Wasn't that very fun? All right. Now is the time that you get to play around. I want you to know that I threw the bleach in the sink. I don't want to play with the bleach. So I hope that if you got bleach or ammonia out, that is not a part of the rest of this experiment. So throw that stuff out and just stay with these non-toxic things. If you were with me in class, this is the time where I would let you take a bowl and mix however many of these that you want together, because that's what fifth graders really want to do. They just want to mix it all up and see what happens. I also encourage you, if you have extra cabbage juice, maybe you have Coke in your fridge, or maybe you have orange soda, or maybe there's another cleaning chemical that you would like to test. Go ahead and pour this into a whole bunch of those things and see what happens. I want you to keep asking questions, and I'm hoping that some of you might become chemists after an experiment like this, because I mean, do you remember what these looked like before and now they look totally different? It's pretty cool stuff. I think chemistry is so much fun, and I hope that you can have a lot of fun with the chemistry too. So ask more questions, play with more substances, see what else you can come up with, and let me know what you found out. I'm so excited to hear about your chemistry adventures. Thank you so much for participating with me, and I hope next year we can do this in person. Love you guys, stay safe, and we'll see you soon. Bye.